Imagine your code fails in production. What you will do? I guess you can fix the bug and deploy it again, right? But what if I say your production environment is space? You don't always have the opportunity to fix the bugs, especially if the production environment is space. And for space mission, remote debugging is not an option yet. That's why NASA developed a strict set of guidelines known as the Power of 10 to ensure their software is foolproof. Crafted by Gerard Holzman at NASA's JP laboratory, these rules are designed to make code not only safe but also perfectly clear for static analysis. While these standards might look extremely prudent, they are absolutely critical in space exploration when the margin for error is zero. Let me share with you, while studying this I realized NASA's approach is really simple and straightforward. NASA's approach to coding is all about simplicity and reliability, and setting a gold standard for safety-critical software development. And that's why they call them the Power of 10 rules for developing safety-critical code. And if you're wondering which language they use, then rule number 8 will explain that. So let's dive right in. And the first rule is simplify control flow. It emphasizes making the software logic straightforward to follow. And this rule advises against complicated programming techniques like goto, recursions, or other practices that make the code hard to read and predict. By keeping the flow of the program simple and predictable, NASA aims to make its software more reliable and safer for missions where there is no room for error. By the way, do you know why they don't use recursion? Because recursion code leads to runway code if not properly managed. If you are a newbie, you might be wondering what is runway code. Runway code is when a computer program keeps running out of control, like it's stuck in a loop and can't stop. It uses too much computer power and finally crash. And definitely no one wants to happen that, especially in space. And the second rule is limit loop iterations. NASA gives all its loop a fixed bound. The idea is to set maximum limit for loop iterations to ensure that loops do not run indefinitely. This is crucial for maintaining control over the program. And once again, presence of loop bounds prevent runway code. And the third is don't use heap memory. And once again, it's really critical in NASA's guideline for writing safety critical code. It advises against using dynamic memory allocation after initialization. Managing heap memory during runtime can introduce complications. Issues like memory leaks and fragmentation may arise. And these problems may lead to unexpected behavior in critical applications. So, NASA prefers to use stack memory, which is automatically managed and safer to maintain program stability. So, by avoiding heap memory allocation, programs become more reliable and safer. It reduces the risk of failure in systems where safety is paramount. And the next rule is keep functions concise. It advises that each function in your code should be short enough to be viewed on a single screen. This encourages simplicity and clarity, making it easier for developers to understand, maintain, and debug the software. And also, limiting the length of functions make it more manageable and easy to understand. Even in modern software development, the principle keep concise functions holds significant value. It aligns with several modern practices like clean code and microservices architecture. And the rule number 5 is mandate minimum assertion density. It says the importance of incorporating at least 2 checks or assertions within each function. These assertions serve as a checkpoint to confirm the software's operate aligned with the programmer's intentions. And this approach aims to catch potential defect early in the development process. And it makes the code more robust and reduce the risk of unexpected behavior in safety-critical applications. And the rule number 6 is minimize scope of data declaration. It advises that variables should be declared in the smallest possible scope. This means you should make variable visible only in that part where they are required. It also reduces the chances of errors since variables are tightly controlled and less likely to be used incorrectly. Declaring variables in a minimized scope can lead to better memory management, especially in language with automatic garbage collection. Also, it helps you to reduce the chances of data leakage and unintentional data manipulation. Of course, which is really critical for those applications who are handling sensitive information. And the rule number 7 is validate non-void returns and parameters. It emphasizes on 2 important things. First, the information that a function takes, known as parameter, and second, the information that a function returns, known as no void returns. This means whether a function is supposed to return a value, you should make sure that the value is what you expect it to be. Similarly, before using the value given to a function, it's critical to check they are valid. This step helps prevent errors and ensure that the program behaves as expected. I simply love this rule, and I can't believe how many times I have seen, especially newbie developers, missing this important rule. And the next rule is restrict preprocessor use. This is very specific to C language, as NASA use C language for their embedded systems. The rule advising limiting the use of C preprocessors to only include file guards and simple macros. Its misuse can lead to complicated, hard-to-read code that can introduce subtle bugs that are difficult to trace. And modern programming languages like C#, JavaScript, Python, and others, they don't have preprocessors in the same sense as the C has. Instead, they might offer similar functionality but differently. And the rule number 9 is control pointer use. This rule suggests using only single level pointer, dereferencing, and avoid function pointers to make code easier to follow and analyze, especially for tools designed to check the code quality. This rule helps maintaining clarity and reduces the chance of mistakes. And rule number 10 is about enforce compilation without warning. It stresses the importance of compiling code with the toughest warning settings from the very beginning of development and addressing any warnings that arise immediately. By treating warnings as errors, developer can maintain higher code quality. It prevents future bugs and ensures the software is as safe and reliable. And this is all about the power of 10. And if you want to use this, you can use it in your current or future project. But if you want to learn more about clean code practices, then here is a video for you. 20 clean architecture tips that any developer can use, beginner or experienced. And thanks for watching.